Okay, so in this video, we're going to take a look at how to solve quadratic equations that don't have real solutions, but this time we're going to do it by factorizing. So before we get into that, though, let's just make sure we can do some factorizing. These first examples use the difference of two squares. So for example, usually you will have seen x squared minus 4 be equal to x plus 2 x minus 2. Now, we're not going into detail about why that is. We should probably know that by now. But clearly, this number, the square root goes here and here, and the number on the right with the minus sign in between goes here and here, right? So we're going to have to be doing some square rooting. Now, that won't work exactly because of that plus sign that you can see. Look, there, it's a little different. So what we're going to do is we're going to cheat. We're going to say it's x squared minus, because then we can use that rule, minus 4, right? Okay, and that is equivalent to our question, okay? So if that's the case, then we can jump in and use that difference of two squares to factorize it. We can have x plus the root of minus 4 and x minus the square root of minus 4, right? Just using the same rules as you saw a moment ago. We can then simplify because, of course, we know a lot of things about complex numbers now. That's going to be x plus 2i and x minus 2i. And to make sure, if you don't understand why it's 2i, you need to go back and look at my previous videos on the square roots of negative numbers. Let's look at part B. It's the same principle, just to check that you can do it. So we're going to write this as x squared minus 11. So then we can use that same rule. And remember, we're just square rooting the two things. We're going to have an x there and there, the square root of x squared, plus and a minus sign in the middle. And then we're going to have the square root of that right-hand side right there in those two things, in those two places. So simplifying, we're going to have x plus the root of 11i and x minus the root of 11i, and we are finished. So now that we've done that, we're ready to solve some equations now, and we'll do this with factorizing. So jumping straight in, let's factorize this. Well, to start with, we can take out a factor of x bracket x squared plus 2 is equal to 0. Now, if you remember how to factorize and solve equations by factorizing, we've got two values that are multiplying being equal to 0. So either x is equal to 0, there's one of our solutions, or x squared plus 2 is equal to 0. So we've got one solution to this already established. Look, x is 0, but let's just solve this right-hand side to make sure we find any other solutions. So we'll move 2 to the right-hand side, and so therefore x squared is equal to minus 2. Now we can square root. So another solution is going to be plus or minus the square root of minus 2, all right? Now, don't forget, it's really important when we're solving equations to remember the plus and minus, okay? These, there are multiple solutions here because if we're squaring something, we could have had a negative or positive to begin with. Right, from there, we can say that we've got plus or minus the square root of 2i. So we therefore have, just to really make sure you understand this, three solutions to this original equation. One of them is x equals 0. The second solution is x is equal to the root of 2i. The third solution is x is equal to negative square root of 2i. Right, let's move on again. Let's try a really quite challenging example here. We've got x to the power of 4 plus x squared equals 6. And you may be thinking, I'm not even sure this is a quadratic. Well, you'd be right, but we can use certain rules to help us. I'm going to do a clever substitution to show you how to solve this. I'm going to say that let's make a y equal to x squared. Okay, now I've made up that. The y could have been anything really, but let's just see what happens if we write that in terms of y now. So x to the 4, well, that would be y squared. The x squared we already know is a y. I'm going to move the 6 across to the left. So I'm going to have a minus 6 equal to 0 there, look. So I've managed to write what is clearly a quadratic equation equal to 0 in terms of a new variable y that I've just made up myself, really. And later on, once we've solved this thing in terms of y, then we'll go back and look at what x could be. So I can solve this by factorizing, right? Because I've got a regular quadratic, there's a coefficient of 1 in front of the y squared. So this is going to be y plus 3, y minus 2. I'm looking, don't forget, for two numbers that multiply to make minus 2 and then add to make positive 1. So therefore, we're going to have that y is equal to minus 3 or y is equal to 2. Now, no one's interested in y. This question was all about x. So now we've got that far. Let's now go back and swap it back out for the x. So we know y is equal to x squared. So therefore, it's x squared that's equal to minus 3. And it's x squared that is equal to 2. So square rooting, we're going to have x equal to the square plus or minus the square root of minus 3. So therefore, it's plus or minus the square root of 3i. On the other solutions there, look, we've got to square root 2. So we're going to have x is equal to plus or minus square root of 2. And we are done, aren't we? Right, okay, so how many solutions do we have? We have 4 different solutions to the original quartic equation. Positive root 3i, negative root 3i, positive root 2, and negative root 2. They're all going to work. Okay, hopefully that helped you to solve some more equations that had complex